Today we're going to talk about something called factoring. And I think you've heard about factoring before, except you've done it with numbers and not variables. So for example, if you want to factor 20, what you do is this is how you find the prime factorization. So you get 10 times 2, 5 times 2. Then the prime factorization of 20 is 5 times 2 squared. So that's prime factorization. But factoring, for example, if you want to factor 60 plus 20, what you do is you find the greatest common factor. So in this case, it would be 20. So what you do is you divide everything in this by 20. So if you do that, you get 3 plus 1. And as you can see, 20 times 3 plus 1 is the same as 60 plus 20. So this is basically the opposite of the distributive property. So that's factoring, because if you use the distributive property on this, you'll get that. So that's factoring, and we can also do it with variables too. So if we have like 2x plus 6y, we can factor this. What's the greatest common factor of 2 and 6? What's the greatest common factor of 2x and 6y? Well, it can't have y's or x's in it because y and x are different numbers, so they can't have the same factor unless they're the same, but they're not because it's x and y. They're two separate variables. So that means we look at the numbers and find their greatest common factors, which is 2. So if you do that, it's the opposite of the distributive property, remember? So it's 2 times x plus 3y equals 2x plus 6y. So that's how you factor that expression. We can even factor expressions with more than 2 variables, like 3x plus 3y plus 3z. You can see that in this case, the greatest common factor is 3. So 3 times x plus y plus z is how you factor this. And you can even factor, we have x squared plus xy. You can also factor this by factoring out an x. So you get x times x plus y. That's how you factor that, because if you use the distributive property on this, you'll get x squared plus xy. And I think that's enough examples for this video. Hope you like this video.